The headlines paint a very specific picture right now. Tariffs hit, trade wars escalate, and multinational corporations pack up their factories, fleeing to places like Vietnam or India to escape the turbulence. But peel back the Made in Vietnam sticker on a modern device and look inside. The logic board, the camera sensor, and the internal battery chemistry originate from the exact same Chinese suppliers they always have. Zoom out from the product itself, and you find the CNC machines milling the aluminum casing are imported from Guangdong. The software tracking the logistics across the border is coded in Shenzhen. For decades, foreign investors operated under a specific assumption. They believed they were simply renting a massive pool of inexpensive labor. The logic followed that as soon as local wages rose, the factories would naturally migrate to the next low-cost country. Over 4 decades, local planners moved beyond basic factory floors to assemble a vertically integrated industrial stack. By embedding every layer of the supply chain, from raw material processing to final logistics, directly into the local geography, they created a system where moving a factory requires moving an entire ecosystem. To see how this stack operates on the ground level, you have to look at the physical concentration of the ecosystem. In 1980, Shenzhen was a border town of about 30,000 people. Today, it rivals New York in size and functions as the electronic hardware capital of the globe. A startup in California designing a new gadget spends weeks hunting down suppliers. They might source a plastic casing from Ohio, a circuit board from Texas, and batteries from South Korea, shipping everything to Mexico for final assembly. If one link breaks, the timeline collapses. Move that exact same startup to the Huaqiang Bay district, and the geography changes completely. Within a single square kilometer, engineers can walk to thousands of vendor stalls containing every microchip, capacitor, and sensor required to build their device. Need a custom prototype printed and assembled? You can walk it down the street and have a working model in your hands within 3 days. This extreme physical proximity, combined with thousands of white-label factories ready to produce off-the-shelf parts for any brand, creates a frictionless loop. Hardware iteration happens here faster than anywhere else, largely because the entire supply chain shares the exact same zip code. Western audiences often imagine a specific type of factory, endless rows of workers hand-assembling products under harsh lights. That low-tech model peaked 20 years ago. In 2023, China installed nearly 300,000 industrial robots across its manufacturing sector. This dwarfs the combined installations of the US and Europe. This surge was subsidized by the Made in China 2025 initiative, injecting billions directly into factory upgrades and AI research. Rather than completely replacing human labor, they run a hybrid model. Algorithms and robotic arms handle the highly repetitive tasks with millimeter precision, while a domestic education system produces over 7 million engineers a year to manage complex problem-solving and quality control. When Tesla attempted to build a fully automated factory in California, they faced severe production bottlenecks. Yet their Shanghai Gigafactory, relying heavily on this skilled workforce to augment the machines, produces more cars at a lower cost than any other global plant. By backing intense robotic automation with a massive, highly disciplined engineering pool, these facilities can scale production instantly. When global demand spikes, they don't simply work longer hours, they expand capacity overnight. Producing goods quickly only matters if you can move them. To ensure components flow between clusters, the state constructed 42,000 kilometers of high-speed rail. That efficiency extends to the coast. Shanghai's automated port operations can unload, reload, and dispatch a massive container ship in under 24 hours. Similar operations in Western ports routinely take 3 to 5 days. The physical roads are mirrored by a digital network of over 3 million 5G base stations. This connectivity allows automated systems in rural provinces to communicate with coastal logistics centers in real time, with virtually zero lag. Then there is the financial engineering. The central bank actively manages exchange rates to keep export prices attractive, while the government waives export taxes entirely. Combine the physical rails, the digital grid, and these financial levers, and you get an invisible backbone that keeps the manufacturing sector insulated from the bottlenecks that often slow competing nations. Because Western companies outsourced the physical creation of their products for 4 decades, they inadvertently transferred the knowledge of how to improve them. The supply chain that controls the physical assembly eventually learns how to design the product itself. Look at the electric vehicle market. A domestic firm called CATL now manufactures 1 out of every 3 EV batteries globally, pioneering new chemical structures that outperform Western alternatives. Meanwhile, BYD surpassed Tesla in total EV sales by competing directly on engineering and performance rather than price. To secure these gains, Beijing initiated a strategy known as dual circulation. The goal is to reduce reliance on foreign buyers by shifting focus to their own domestic market of 1.4 billion people. With a consumer base that large, local hardware companies can test, refine, and scale complex technologies completely internally. They achieve profitability before a single unit ever crosses an international border. To protect this ecosystem from external pressure, state investments are heavily concentrated on securing global choke points. Look at this map of the tech supply chain. International pathways consistently route through domestic nodes for rare earth materials and advanced semiconductor processing. By dominating these specific bottlenecks, they create a fortress economy, surviving isolation while maintaining intense leverage over global supply chains. The global market spent the late 20th century looking for a cheap, temporary workforce. Instead, it funded and trained an interconnected industrial organism that now dictates the future of hardware.